Hello, myself Dakshayanisi, working assistant professor of chemistry, Government College for Women, Autonomous Mandya. Uh, Today I am going to discuss about the topic phase equilibrium part 2 for the course BSc subject chemistry and the paper physical chemistry. In this session contains one component system, that is the water, and another one, that is a one component system of that would be sulfur, as an taken as an example. Here already discussed in the previous session and the part 1 phase equilibrium, that is a one component system of that one water. That we must know from the previous session, that will be if it is a one component system, in that is in a bivariant, it can be completely defined by specifying two variables. The two variables are the temperature and pressure. So once that is you are going to at a particular temperature and a particular pressure, so you are going to thermodynamic equilibrium, that is a very that standpoint of view, then you are going to get there will be a sulfur that will be exist in the four phases. As we know from the previous session and also from the previous whatever the in the part 1, that will be a water that will be exist in the three phases, and it will be coexist in the on the particular point at a particular pressure. Therefore here, because of that is, if it is a one component system, it will having that is a more than three phases, then it is not coexist all the four phases at a particular point. Therefore in this sulfur phase diagram, so there will be a several coexist point that will be appear. So we are going to discuss in that. Here that is whatever that will be, once we are going to a thermodynamic equilibrium of the verified specified standpoint of view, if you measure that one, if you go for that one, then there will be so much, there will be a curve, this kind of the phase diagram that will be appear. If you go for the curve, that will be AO, that is what we called as a sublimation curve of a rhombic sulfur. So as we know that is a sulfur exists in the two crystalline form. One is the rhombic sulfur, another one is the monoclinic sulfur. So rhombic sulfur below 95.6 degree. So rhombic sulfur is stable in nature, and above 95.6 degree, that is a monoclinic sulfur that will be stable in nature. So at after that's a 95.8 degree, that is rhombic sulfur that will be a converted transition to its a monoclinic sulfur, as a monoclinic sulfur. Yeah, that is AO curve, that is what we called as a sublimation curve of rhombic sulfur. This curve, that's where a coexist in between, that will be equilibrium between the rhombic sulfur with its vapor state. And by using the Gibbs phase rule, we know that this is a monovariant. Like that only, if you increase that temperature, that will belong, that is a OB, this one what we called that after 95.5 degree centigrade, that's a monoclinic sulfur that will be stable in nature. This OB, that is what we called as an OB, that's a sublimation curve of the monoclinic sulfur. So this monoclinic sulfur, that's OB curve, it is also a bivariant. That will be a I mean that by in the bivariant, it is not in a bivariant, it should be a monovariant, because of here this OB curve, that will be equilibrium exists between the monoclinic and also with the sulfur vapor. So therefore this is also a monovariant system. This whatever that will be this transition or in a equilibrium that can be from one form to another, that is easily we are going to identify by using Clausius-Clapeyron equations with the change in the pressure with respect to change in the temperature. Then you have to which is equal to enthalpy of whether that will be a sublimation curve or in a transition, that is easily we are going to identify that one. So next we go for the one when the B, that is the temperature increases along, that is the BE, then there will be exist in the, that is sulfur exist in the vapor form, and also at you are going to increase a sum of, that is the pressure on that, and it is in the short period of that one there will be a sulfur is also exist in the liquid form. So that when the liquid form it is about 144.7 degrees centigrade to 150 degrees centigrade. So then above 150 degrees centigrade, that will be a liquid sulfur gas at a particular pressure that will be absorbed. So you must you know that at 150 degree centigrade, that is liquid form that will be appear at a is our corresponding pressure it is there. So here that is a BE curve, that is what we called as a vapor pressure curve of that sulfur. So this BE is also monovariant, and there will be equilibrium exists between the sulfur in the liquid form with the sulfur that will be in the vapor form. So here that is a B, it is also another a triple point here, or that is all the curve, that is what we call the fusion curve of, that is the rhombic sulfur. Another one is the BE, that will be vapor pressure curve, and the sublimation curve that will be coexist at a particular point at 120 degree centigrade, and this is also another triple point, and it is because of three phases coexist in the point B, so this one is an invariant system. So like that it is where some, that is 144.7 to 150 degrees centigrade we are going to observe at a if we increase the pressure in that, we observe the fusion curve of, that is the monoclinic sulfur that will be appear, that will up to 150. Therefore this curve it is very short than that of this transition curve, and which is inclined far away from the pressure or line there. So this fusion curve, that is the BC along BC, then the whatever that is the, we are going to point out any thermodynamic verified standpoint of view, then there will be a that is the equilibrium between liquid and also monoclinic sulfur, and here it is also it is the univariant. So that is the another curve that will be a OC. This is what we called as a transition curve. This transition curve, it is also a monovariant because of these two solid state will be there, and this curve that is this line, that is what we called as a transition curve. So when you extend that one C to D, this is also what we called as a fusion curve of rhombic sulfur. So here that is CD, it is also a monovariant. Then there will be exist between the solid sulfur to the liquid sulfur. So therefore this is also a monovariant. Then another triple point, that will be all the three that say coexist in the point C. It is that will, what is that fusion fusion curve of the monoclinic sulfur, and the fusion curve of that will be a rhombic sulfur, and also that is transition curve, or that will be all the three that will be coexist and at a particular point C. This C is also we called as an what we called as a triple point, or also this is a invariant system or the invariant system it is there. So this is also another triple point. So another one that you know that if we extend, that is the OA curve, that is the OA dash here. So there will also be called as a metastable equilibrium that will be exist in that. This is the another triple point at 114 degree centigrade. Yeah, that is why this it is not only this OA, and also there will be, you are going to cooling that this along EB up to, you are going to extend up to, that is a BA dash, that is what we call as cooling off, that is a monoclinic sulfur. So then what happens to that this BA curve, it is also one of the meta stable equilibrium state in that that A at 140 degrees centigrade here all the three, that is the it will be a monochloric sulfur, and the whatever that will be a vapor pressure of curve of that one extend to that one BA, it is also a BA dash curve, and OA dash, all are coexistent at 114 degrees centigrade. This is also be called as an invariant because of all the three that will be in the solid, vapor, and also it is another rhombic sulfur coexist in nature. So it is another metastable invariant system will be there. So this is the one thing we must know, that that's above, that will be 150 degree centigrade, and at under 1290 atmosphere. So here that will be another, that will be a C. We are going to extend that C to up to CA dash. Then there will be a conversion of, that is at the, that is a cool, and the pressure that will be it will be a decreases in that. Then what happens to that, it will be, you are going to appear in that, that is as an monoclinic sulfur. This is also a univariant, this one is also univariant, and this is also a univariant. All the three exist at a point A. So why you are going to get a metastable equilibrium in that? Because of due to a transition from a rhombic sulfur to the a monoclinic sulfur, then there will be a molecular arrangement that will be necessary for bringing about from that will be a time required from, that is the one rhombic sulfur to a one crystalline form to the another crystalline form. Therefore then there will be that process that will be a very low. Then there will therefore it will appear in that a three form of three curves that will be in that, in the metastable equilibrium curves will be there. So this is the one another triple point. Therefore here that will be a four triple point in that we are going to get, that is the three in that one from the metastable equilibrium. So it is the below that will be a O, BO, and BE, that will only a vapor state of that sulfur that will be appear. Above that, when above that one, then there will be a liquid and solid, and also that is a monoclinical also appear in that. So in the triangle that will be in the area, that is BC, CO and OB, that will be a monoclinic sulfur that will be a stable in that in the triangle curve here. So This is what is there. This exists and form of this monoclinic sulfur is limited in all the sites. By using this phase diagram of that sulfur, then you can easily identify by using Cauchy's Clapeyron equations. Then we can calculate it with a change in the temperature with the pressure, or a change in pressure with a temperature. You can find out the enthalpy of any kind of the transition, whether it will be a sublimations or vaporization, all those things by that equation. So here that is the I'm going to discuss about this area of that curve, that is the AO and OC, and that is a rhombic sulfur in equilibrium with vapor phase. That is already know that curve AO, OB and BA have the vapor phase as a common. The area lying below these lines represent only vapor as the stable phase. The line OC, OB and BC have a monoclinic sulfur as the common phase. The triangle area bounded by these lines represent monoclinic sulfur as a stable phase. And these are the references and sources for the making study materials and also this video. Thank you.